The Titanic. Behind the story of the most legendary ocean liner lies a little-known tale of the adventurous, pioneering men determined to push the limits of the possible. Their incredible technical achievement in the shipyards of Ireland included the construction of not just one, but 3 ocean liners, the largest in the world at the time.
They really were planning on way larger ships than anybody had ever seen.
Imagine being on a mission to Mars or something. That'd be the closest thing we can come to today.
They really thought that they could potentially conquer nature.
Think you know all there is to know about the Titanic? Think again, and watch as we reveal some of the intriguing, overlooked backstory of history's most famous ocean liner. It all started in 1908 at the Harland and Wolff shipyard in Belfast with the construction of a massive, revolutionary building framework. For nearly 3 years, 6,000 people dedicated their lives to making the crazy dream of creating these colossal vessels come true.
Building the slipway and the gantry was a massive undertaking.
They need to make these changes because it's simply not possible to build these ships.
The Titanic's epic adventure started with its first rivet. The hull alone took 2 years to build. It sprang from the farsightedness of bold, visionary men and new cutting-edge tools and techniques.
The jaws of this sea clamp would compress these rivets together, perfectly compress them, fill the holes up.
When the Titanic was built, everything was designed and made by hand.
The slightest error could compromise the actual quality, stability, and operation of the ship itself.
The ship's launch was an international event, carrying tremendous risk. The thrilling culmination of a formidable technical challenge with no room for error.
Titanic's size is unprecedented, so they don't really know 100% what may or may not go wrong.
For 60 seconds, they get to see the largest object moving on its own for the first time.
And the saying is, if a ship can survive its launch, it will survive anything.
They don't say that anymore, but while it lasted, the ship was spectacular. Now, through exceptional 3D reconstructions, extraordinary colorized footage, animations based on historical photos, and insights from the world's leading experts on the Titanic, we're about to embark on a tour of the ocean liner of the century. All aboard the Titanic, Genesis of a Giant. Belfast, Northern Ireland. This is where the story of the world's most infamous ship began more than 110 years ago, at a turning point in modern history. In the early 20th century, the world was fascinated by the idea of the American dream. Thousands of people dreamed of trying their luck in the new world full of promise. The only way to reach America was by one of the most dangerous routes known to man, the North Atlantic Ocean.
It's hard for us to imagine this, but outer space was unthinkable in those days. So really, the outer space of that time was the Atlantic Ocean.
The Atlantic Ocean is seen as the end of the world, like there's nothing beyond it. But as immigrants, there's freedom, there's choices.
To get across the Atlantic, you couldn't get in a jet plane. They didn't exist yet. To get across the ocean was the ocean liners.
In this context, with such high demand, the European and American shipbuilding industries were growing quickly. Maritime companies competed with one another to offer the largest, fastest ocean liners on the market.
There was a race for whatever country could create the fastest ship. But at some point, technology just kind of eclipsed the progress of the public utilities.
They really thought that they could potentially conquer nature. Bigger is better. The more people you could fit on a ship, the greater the profit, and so the ambition was virtually unending for size, scale, and speed.
Two British companies dominated the market, White Star and Cunard. These two competitors were locked in a fierce battle to beat records and attract as many passengers as possible, wealthy and immigrants alike. In 1907, Cunard introduced two monsters of the ocean, liners whose size, weight, speed, and capacity were unprecedented, the Lusitania and the Mauretania. With these two giants of the sea, the crossing from Southampton to New York took less than 6 days, a new record. This astounding human and technological exploit was a bombshell for their competitor, the White Star Line. Management knew they couldn't beat Cunard's advertised speed of 27 knots, the equivalent of 50 kilometers per hour.
White Star are worried. Lusitania is the fastest ship in the world. It has revolutionary turbine technology. White Star don't think they can compete, so they don't look to speed. Instead, they turn to size, luxury, and safety.
They're going to give you luxury and stability and a lovely calm ship, and they're going to make them the biggest in the world so that you'll feel that you're special when you're traveling on them.
That is why they look to building the Olympic-class ship.
Olympic-class ships. This dizzying, unprecedented project involved the construction of 3 ocean liners 30 meters longer than the Lusitania or the Mauretania, at 270 meters long, 28 meters wide, and 53 meters tall from the keel to the tops of the funnels. All this with a total capacity of 3,500 passengers and crew members, weighing more than 52,000 tons, the equivalent of 180 Airbus A380 planes. These 3 ships would be the longest, heaviest, and largest ever built.
They really were planning on way larger ships than anybody had ever seen. They really were exceptional ocean liners.
This is an absolutely monster project in every regard.
Their construction was made possible by American banker John Pierpont Morgan, who spent more than £1.5 million sterling at the time, the equivalent of $150 million today, on each of the 3 liners. Although these steel giants were designed by British architects Alexander Carlisle and Thomas Andrews, they came from the minds of 2 men. Bruce Ismay, the chairman of White Star Line, and William Peary, the greatest shipbuilder in the world.
Peary has this great ambition to be the man to make the first 1,000-foot-long ship. They come up with names, arguably competing with Cunard's use of Roman province names. White Star turns to the Greek and the great gods. You have Olympic, and of course their great rival, the Titans, Titanic.
The first 2 Olympic-class ships were built at the same time, with work on the 3rd beginning once the first was put into service. Their ultimate goal was to have enough ships in service in order to offer weekly transatlantic crossings.
That was the ideal. So you wanted ships going both directions simultaneously for consistency in passenger trade.
Once every week, you could take one of these great liners. It would be in New York once every week. They would just rotate them out.
The construction of these gigantic ocean liners was entrusted to the leading experts of the time, the Harvard and Wolff Shipyard in Belfast, Northern Ireland. For 50 years, these shipbuilding pros had used their imagination to push the limits of technology and make people's wildest dreams come true by building floating palaces that grew more extreme in size each year.
If you didn't work in Harland and Wolff, your nearest relatives did. Everybody knew someone who worked in Harland and Wolff. It is like its own city.
It's like GM in Detroit. Most of the people that live in Detroit work for car manufacturers. Well, most of the people in Belfast work for Harland and Wolff. That's a lot of people.
Before they could start work on the project, the experts at Harland and Wolff had to completely rethink their shipyard. They reconfigured their infrastructure to be able to build these juggernauts of the sea.
Just getting the shipyard ready was a massive undertaking in itself. They had to build gigantic pieces of infrastructure in order to be able to build the Titanic.
The existing shipyard is modern and it's one of the largest in the world. Nonetheless, they need to make these changes because it's simply not possible to build these ships.
The length of these ships was so extreme that there was no slipway in the world that was large enough. The engineers at Harland and Wolff were forced to destroy 3 existing slipways and replace them with 2 giant new ones. At 260 meters long and 80 meters wide, the size of 3 football fields, they were the largest slipways ever constructed, large enough to build the Titanic and the Olympic side by side.
It is the first time that 2 such large ships are built together in the same shipyard at the same time. This challenge is enormous.
The timing of the entire project depended on this first massive undertaking. The Olympic and the Titanic were due to go into service in the summer of 1911 and spring of 1912. Even the smallest mistake could have catastrophic consequences.
Once the shipyard had announced the ship would be ready to go into service on a certain date a few years in the future, they had to stick to that deadline.
The construction of these floating palaces consisted of 3 major phases. First, the building of the hull, the most time-consuming step. Second, the launch, a complex step. And finally, the fitting out of the ship's interior.
So the highest technology that they had, the greatest technology, went into the ocean liners.
The construction of the 2 vessels required the invention of a revolutionary gantry capable of lifting large pieces of metal above the 30-meter high hull. The engineers entrusted this task to architect William Arrow, the Gustave Eiffel of Britain. The construction of massive ships called for massive tools. The architect designed the largest steel structure in the world.
So William Arrow is the man who's put in charge. He's given the contract, and within a couple of years, he delivers a structure which is unrivaled, so much so that it was used right up until the late 1960s.
An incredible 70 meters tall, this gigantic metal gantry weighing 6,000 tons straddled the slipways where the Titanic and the Olympic were being built. It was composed of a movable central crane and 10 electric cranes on rails, each capable of lifting up to 5 tons.
You have cranes to do the heavy lifting, to lift huge big pieces of steel plate into position. You have lifts so that the workers can get up to the top. You've got all sorts of mechanical ways of getting people and things from place to place.
The Arrow gantry was like a small city in itself. There were hundreds of people working there every day.
Like a domino effect. One domino knocking down another domino, just to get to the point of to be able to start building these things.
March 22nd, 1909. Work on the Titanic could finally begin. Nearly 14,000 people were employed at the Harland and Wolff shipyard in Belfast. 6,000 of them would end up working on building the ocean liners of the century. By the time construction on the Titanic began, work on the Olympic had been underway for 3 months. In the neighboring slipway, specially designed wooden blocks had been put in place in preparation for building to begin. These blocks would be used to build the first part of the ship, the keel.
The first step in building a ship is to lay the keel. It is a symbolic moment, a bit like laying the first brick on a building.
This is quite literally the backbone of the ship. If you imagine the spine in a skeleton, everything hinges on this particular part. It needs to be absolutely straight, absolutely level. It's imperative to get this correct.
The keel was composed of several laminated steel beams assembled at the bottom of the slipway. These beams formed an immense metallic bar 50 centimeters wide and extending the entire length of the ship.
The keel, this central piece, is really the foundation for the entire boat.
2 months later, a new phase began, one that would determine the solidity and the safety of the ship, the construction of the double bottom. This double layer of metal boxes was a formidable shield against a ship's greatest enemy, flooding.
A few decades earlier, they had realized the key to keeping ships afloat. In the case of a hole in the hull, there had to be a way to keep water from getting into the rest of the ship, or it would sink.
If anything happened, if you hit a rock, you could simply be towed off of it, you wouldn't sink, you go back to the shipyard, they repair the bottom, you'd be fine.
That safety element really defines the Olympic-class project to get these ships as safe as possible and to utilize these newer ideas to ensure the safety of Titanic.
The construction of this double bottom was quite a challenge. The metallic pieces were assembled using a technique called riveting.
Riveting was the superglue of its day. If it's metal, it was riveted.
When they built the Titanic and Olympic, such a big ship, they used the same techniques as other smaller ships, but not really sure how it's all going to turn out.
3 million rivets were used to build the Titanic. 1/3 of them were put in place using cutting-edge technology. This enormous machine, a hydraulic riveter.
This is a new technology using giant pincers supported from an overhead crane. They're very fast, very efficient. It creates a very strong rivet, a very tight bond.
They would put these into pre-punched holes, and the big C-clamp, the jaws of this C-clamp would compress these rivets together, perfectly compress them, fill the holes up.
It was very expensive, but it ensured the rivets were put into place correctly.
July 1909. 5 months after the construction began, the men started building the body of the ship, putting enormous frames into place. In shipbuilding, these are known as ribs. They provided the support structure for the steel sheets of the Titanic's hull.
Frames, also known as ribs, literally like the ribs in a skeleton. They perform the same process. They create the shape of the hull, but also it is, of course, the main structural element, which, of course, everything else links into.
The rib cage of the Titanic was composed of 300 pairs of 20-meter-high ribs. These ribs were a work of art. First, they were meticulously designed by the shipyard's engineers. The next part of the job was entrusted to an army of draftsmen who had to turn the schematics into life-size pieces of metal in this hangar the size of a football field.
All the pieces were designed, calculated, and built in a massive room at the Harland and Wolff shipyard using chalk. In the time of the Titanic, everything was designed and made by hand.
And the frames are drawn out on wooden boards, which are clamped together. They're chalked out, and then they're scribed with a special knife. And it's this process where they check the lines plan to make sure that all the lines intersect at full scale properly, so that when they actually create the frames fit together where they're supposed to.
Any distraction could be massive in terms of consequence. The slightest error, particularly when you're converting scale drawings to the life size, the potential for error could translate into faulty parts of the ship. At best, this wastes time, but at worst, it could compromise the actual quality, stability, and operation of the ship itself.
And these pieces had to be put in place with the utmost care, otherwise the consequences would be catastrophic. The risk was that the ship could become unstable and tip over inside the slipway or when launched into the water.
So when you're putting these frames in place, 66 feet tall, these are not small pieces of metal, you want to ensure that you're fitting them levelly to get the shape done correctly, symmetrically, but also to ensure the stability of the vessel on the slipway as you're building it.
Ships are not built to be on land. The taller the structure gets, the more its center of gravity moves, which presents a new challenge to overcome. The hull must be kept very straight or be subject to dramatic consequences.
If a ship were to fall over during the construction process, particularly in the confines of, say, the gantry, the amount of damage which it would do, quite aside from the risk to those actually working there, could have been absolutely catastrophic, not just for the ship itself, but for the gantry and for the immediate area around.
So they supported the structure of the ship with massive wooden beams to reinforce and hold the ship in place inside the slipway.
You can't point a laser, you can't just electronically make it happen. These guys with a pencil and a saw are going to have to work off the plans that they've been given by the draftsmen and make sure that they have this absolutely inch perfect.
At the same time, the workers put the interior frame of the vessel into place. Hundreds of metal columns and crossbeams reinforced the hull of the Titanic.
You have to imagine it like a sort of massive grid with pillars to help the ship keep its shape. Otherwise, the hull would quickly become deformed.
It all is a process, you know, that all works together. You can't just put up the shell plates without putting internals up to hold it up.
April 1910. More than a year after the keel was laid, the structure of the Titanic's hull was finally complete. It was now ready to be covered in its metal casing. This sheath was composed of 2,000 sheets of steel. The largest measured 10 meters long by 2 meters wide, and they were an average of 3 centimeters thick. Each sheet weighed nearly 4 tons. These rectangular sheets came from the best steelworks in Ireland and Scotland.
Steel is used and tested to the highest standards of Lloyd's Classification Society to make sure that the steel is of the right quality and the right strength to use on such a large ship.
Titanic's metalwork was perfectly acceptable for the day. It was about as good as you could possibly get.
Once the sheets arrived at the Harland and Wolff shipyard, they were sent to the workshop, where holes were drilled in them with the utmost precision. These holes were meant to be filled by the rows of rivets that would render the Titanic's hull perfectly watertight.
You have two metal plates overlapping each other, and they have holes in them, and you line up the holes, and then you put a red-hot rod through there.
Two million wrought iron rivets were set up using the traditional method of manual riveting. This meticulous work was done by teams of hand-picked professionals whose reputation and expertise were recognized around the world, the riveters.
The riveting gangs have a very difficult task, and as such, they are highly respected, like the leading figures in the film.
And a good riveter was worth their weight in gold. These men were paid per rivet that they put in.
The teams were often made up of 5 people. Each person had a specific role to play. Speed was key to their success. The riveters had a very narrow window, just 10 seconds to put each rivet in place on the hull before the metal would change temperature.
If it goes below the correct temperature, it won't seat properly, and they'll have wasted their time, which not only wastes materials, delays construction.
Two years after the keel was laid, the Titanic's hull was finally complete. The upper bridges were finished. The internal structure was fully assembled. It was perfectly watertight. It was an incredible feat. There was no man-made structure like it in the world.
There was a young boy, John Parkinson, whose father worked on Titanic, and as a Sunday treat, he was taken down to see the new ship Titanic. And as he stood there, he looked in both directions and he could not see an end to the ship. It was just so massive, it blotted out the sky. And he asked his father, how can such a big ship stand up in the water? His father replied, son, that big ship will always stand up in the water.
You claim that you can fix this radio set, so it'll tune in programs that were broadcast 20 years ago.
May 31st, 1911. The Titanic's hull was about to enter the water for the first time. The cream of Belfast society and its leading personalities were invited to celebrate the event. International media outlets were on the scene to immortalize the launch of the largest ocean liner in the world.
Launch day. This is a major day for Belfast. This is like a space shuttle launch. People around the world are interested.
About 100,000 people are lining the banks to watch as Titanic comes off the slipway. They've paid a shilling to do so.
It was the result of many months of work. It was a bit like the official baptism of the boat.
The launch was a moment of great tension for the designers of the ship. The Titanic was an immense shell weighing 24,000 tons. This crucial step would confirm whether or not it was built correctly, and as such, the designers watched with some concern.
Launching something that's heavier than anything you've ever launched before, and certainly bigger than anything that's ever been launched, will it end up upright?
Is it going to be a triumph? Is it going to demonstrate just how successful the future prospects of this ship are going to be? Or is it going to be an embarrassment? Reputations are on the line here.
In order to prevent such a catastrophe, the operation was planned down to the last detail. First, the workers would remove the wooden block supporting the Titanic's hull, a delicate operation.
They had to remove the elements holding the boat in place at the last moment, and in exactly the right order, so the ship would remain stable until the last possible moment.
A poor man got his legs trapped underneath a couple of days before launch when they were knocking away the staging, and that he died from the injuries. Some people say she wasn't launched in champagne, she was launched in the blood of that man, James Dobbin.
Before it was even launched, the Titanic already had blood on its hands. A total of 17 workers died during the construction of the biggest ocean liners of the century, 8 of them on the Titanic alone. The only things left holding the hull in place were 2 hydraulic jacks. But even though the hull rested on a slipway with an inclined floor, the engineers still had to ensure it would slide into the Logan River according to plan.
Gravity, of course, is going to do the vast majority of the work, but there's a lot of friction. So they coat the slipway with 22 tons of soap, oil, and tallow. Apparently it smells disgusting, but it's just the amount of lubrication which is needed.
It was 12:13 p.m., the hour of truth. All traffic on the Logan River was brought to a halt. Distress flares signaled the departure. Silence fell beneath the aero gantry.
When the signal goes for the launch to take place, the hydraulic is released, this hook folds back down again, and there's nothing holding Titanic back. This piece drops down, which of course is the final brake holding Titanic.
And then the weight of the ship just pushes it down to the water. Really, the launch was, you'd hold your breath.
To come from a city like Belfast on the edge of Europe, you have the biggest man-made object ever moved, sliding down that slipway. That is an amazing thing to get your head around.
At that point, it is the largest moving object in the world, and they know it. And so for 60 seconds, they get to see the largest object moving on its own for the first time.
The launch went exactly according to plan, as hundreds of people looked on in fascination. The hull reached a speed of 12 knots, a danger in itself.
If you're going to launch a 24,000-ton ship, as it was at that point, into the river, you have to make sure that you can stop her. Otherwise, she's just going to float into the other bank.
They had to take measures to ensure the boat would not move too far forward as it entered the water. They decided to use 80 tons of chains and anchors to hold the Titanic back and slow its entry into the water.
They are so successful that from completely on land to completely in water, Titanic only moves twice her length. This was the way that they were able to control this elsewise completely uncontrollable event.
The saying is, if a ship can survive its launch, it will survive anything.
At this point, she is completed as a piece of naval architecture, but there is now the change between converting an ocean-going shell into a floating city.
In June 1911, the hull of the Titanic was taken to Harland & Wolff's fitting out quay. Built specially for these three ships, it was the largest in the world at the time. This is where the interior of the liner would be completed. The Titanic was supposed to be ready for its inaugural voyage just 7 months later. They were running on a very tight schedule. The designers could never have imagined the mishaps that awaited the shipyard. It all began with the integration of the heaviest parts, the beating heart of the ship, without which this giant of the ocean would remain immobile, the propelling machinery. The avant-garde technology of these engines far outweighed their competition.
The Harland & Wolff shipyard and the White Star Line decided to equip the Olympic and the Titanic with a combination of two different types of propelling machinery, reciprocating engines and steam turbines.
They already had turbine technology, they already had reciprocating engine technology, but to combine the two together was unique.
These components were made in the Harland & Wolff warehouses. They were built at the same time as the hull. They were shining examples of technology and human ingenuity.
The engines of Titanic were the largest built at the time, 4 stories tall, triple expansion, 4 cylinders.
The engines in particular are like a model kit. They're built on land, tested thoroughly to make sure that they work, and then they're subdivided into all the major components.
The most iconic elements of the Titanic were its 29 enormous furnaces. Each furnace was 5 meters high, as tall as a house, and designed to consume 600 tons of coal per day during the transatlantic journey. They were the epitome of human ingenuity, reflecting their designers' incredible skill. Making them was a challenge in itself, and installing them on the Titanic was no easier.
It was a very difficult maneuver because the parts were very, very heavy and they had to keep the balance of the ship in mind. So they proceeded with great caution.
Each furnace weighed nearly 20 tons, the equivalent of 20 cars. There was no British crane capable of lifting such a heavy load. That is why the shipyards called on a German company that had perfected a machine unlike any other, the Titan crane. Capable of lifting more than 150 tons across ranges of several meters, this massive metal structure cost the modest sum of 30,000 pounds sterling at the time, the equivalent of 3 million euros in today's money.
The crane is a massive affair. It's got its own power source in order to operate the winches, the jib, or the various gear, and similarly to be able to counterweight the weight of what it's carrying.
It's floating in the water, so it has much more ability to go around the ship as needed and drop things into place.
When the furnaces arrived on the fitting out quay, the Titan crane picked them up and moved them into position for the next step. Each of the parts had to be carefully lowered into the hull through these enormous holes.
When they constructed the hull before launch, they left large holes through all the decks so that you could lower the engines and boilers into the ship.
There is not a lot of spare room. And so you're getting them into position, hand signals, passing messages backwards and forwards. Eventually they get down into the boiler rooms. Of course, you then have to move them into position.
They had to use incredible precision when operating the crane. They also had to take into account the winds that were pushing the boat around, making the maneuver even more complicated. The risk was that they might damage the interior structure when lowering these monumental parts into place.
You have a huge amount of skill and brute force needed to make sure that they go in just the right place, because there is no room for any error at all.
Once the parts had been lowered into the hold, a new challenge awaited the workers. These parts, each weighing several dozen tons, had to be put into exactly the right place in predefined positions in a very precise order. This rigorous positioning process had a direct impact on the balance of the ship. The designers of the Titanic had planned for a crane to be built inside the ship to move these gigantic parts around.
A small hand crane, mostly intended for maintenance during the operation of the vessel. But ultimately, between that and brute force, you're then piecing the engine back together again and linking it up with the rest of the infrastructure of the ship.
At the same time, many other professionals were hard at work fitting out the interior of the ocean liner. Plumbers, electricians, and carpenters all did their part to turn the Titanic into a floating palace.
On the outside, you're finishing off the superstructure, but inside, you're now making it habitable. You're putting in all of the fixtures and fittings, which are turning what is in essence just a metal box into the luxurious accommodation to rival anywhere on land.
Nearly 2.5 years after construction had begun in the Titanic, it was finally time for the moment everyone had been waiting for: the installation of the funnels. The 4 monumental cylinders were over 20 meters tall, as high as a 6-story building.
They were said to be wide enough for 2 trains to pass each other inside. So this was a massive undertaking. They were built on site, then had to be moved and lifted into place by the giant crane. The funnels also had the distinctive characteristic of being a single piece and arrived on the fitting out quay in one piece. The Titan crane, which the shipyard had bought, was used to move them directly from the quay onto the upper bridge of the boat.
The installation of the funnels was a huge technical challenge. They had to be positioned more than 20 meters above the holes specially designed for them. The smallest error could be fatal.
The worst thing that can happen is if the funnel is dropped when it is being lifted onto the ship, because that would cause enormous damage. You do not want this to go wrong.
The Olympic-class ocean liners had one very interesting distinguishing characteristic. Technically, only 3 funnels were needed to vent the smoke from the engine's furnaces. But it was out of the question for White Star's ships to have fewer funnels than the ships built by their rival, Cunard. So the designers added a 4th funnel and came up with an innovative use for it.
White Star wants to make sure it's at least on a par with its main rival. The 4th funnel, some people refer to it as a dummy funnel, but it did actually have a use. It was for ventilation, also to go down to the kitchens to let the kitchen smells away. So it's not doing nothing. It does have a very distinct purpose.
Inside the ship, the Titanic was starting to take shape. The cabins and living areas were designed around the 15 metallic dividers that spanned the hull from the keel halfway up the boat. In addition to the double bottom, the partitions were an extra safety measure in case of flooding, dividing the ocean liner into 16 completely watertight compartments.
These watertight compartments divided the hull of the boat into a series of compartments that were independent from one another, so that if water were to start coming into one of them, it would only affect one part of the boat rather than the entire structure.
Until the Titanic, ocean liners were able to stay afloat with 1 or 2 compartments flooded. The designers of the Olympic-class liners pushed the limits to the extreme by building ships that would be even sturdier in the case of a disaster.
What are the odds of 3 compartments being damaged? Well, not 2 million to 1. It might be 10 million to 1. The odds go up exponentially the more compartments you add. The Titanic was designed to float with 4 contiguous compartments damaged.
Being designed to cope with such a level of flooding without risking the ship was a remarkable achievement. It's part of the reason why Titanic was known as a lifeboat in her own right. This was pushing maritime safety as far as it had ever gone before at this time.
That's not to discourage people on modern cruise ships. Modern cruise ships cannot float with 4 compartments flooded. Titanic could have.
The Titanic's visionary engineers explored new technical possibilities to push the limits of human achievement to the point of perfection. These dividing walls were obstacles for travelers who wanted to move between compartments on the ship. To solve this problem, they developed watertight doors that used futuristic technology.
These are vertically operating watertight doors with a triple system. They can be operated manually. They can drop straight down if necessary. They're also electrically operated, so they can be closed by remote control from the bridge.
But they also had a flotation device so that if water hit them, they would close. And that way, if the power went out, they would still close in an emergency.
These doors, the pinnacle of naval construction, could also turn out to be an Achilles heel. As a result, their design was the focus of much attention. They had to be perfectly watertight in order for the compartments to fulfill their intended function.
If the watertight doors do not close properly, then the watertight bulkheads are effectively useless because the water can simply flood into other areas of the ship.
The efficiency of these watertight doors and dividing walls would be put to the test on September 20th, 1911, a key date in the construction of the Titanic. The Olympic, which had been in service for 3 months, was beginning its 5th transatlantic crossing from Southampton to New York. On its way out of Southampton in southern England, it came across a Royal Navy ship, the Hawke. Unfortunately, Edward Smith, the captain of the Olympic at the time and future captain of the Titanic, didn't leave the Hawke enough room, and the warship collided with the liner.
The Hawke was a cruiser designed for ramming other ships in combat, so it did a substantial amount of damage. The propeller shaft was damaged, and the Olympic had to turn back.
The collision severely damaged the hull of the ocean liner, tearing a 12-meter hole beneath the waterline. Water rushed into 2 compartments, which were cut off from the rest of the ship when the watertight doors closed in time. Fortunately, there were no passengers in this part of the ship.
It was very impressive because the ship handled the collision very well. The Hawke withstood just as much damage as the Olympic, if not more, so the incident helped prove how sturdy these massive ocean liners were.
So a legend was born. One that Harland and Wolff and White Star do very little to counter. A proposed but never released brochure reading, "So far as it is possible to do so, these 2 wonderful vessels are designed to be unsinkable."
While the proof of the Olympic sturdiness may have been an argument in favor of the White Star Line, this accident only created more work for Harland and Wolff. The ship was taken to Belfast to be repaired in the enormous dry dock known as the Thompson Dock. It was specially designed for these unsinkable boats and was unlike any other dry dock in the world.
The dry dock is an amazing piece of engineering. It looks like a big Titanic-shaped hole in the ground, but it is so much more than that.
It was the only dry dock in the world that could handle ships the size of Olympic and Titanic. It was the only place.
The dock was filled with water to bring the ship inside. Once the boat was in place, the enormous ship door was closed, and massive pumps emptied out the 23 million liters of water in a record time of just 1 hour and 40 minutes. Simultaneously, enormous wooden struts were put in place at precise locations to keep the 52,000-ton ship upright.
And we look at it today and say, that's crazy. But, well, that's where they did it. You had to put them in the right spot because, and many of them, because otherwise, because one, it would punch through the hull, the ship would still keel over.
The directors of Harlan and Wolff had to reassign some of the people who were working on building the Titanic to complete the repairs on the Olympic instead.
It took 6 weeks to repair this steel monster. It cost a total of £100,000, the equivalent of 11 million euros today, a genuine fortune. These repairs had a direct impact on the timing of the Titanic and would have tragic consequences.
They were hoping to do the maiden voyage in March, and they weren't able to do it, and they had to push it out until April. And so it did have an effect on it.
Early advertisements said it was to be in January for the maiden voyage of the Titanic. I wish it had been. There were no loose icebergs in January.
January 1912, the Titanic was nearly finished. In 3 months, it was supposed to be in New York. It was now its turn to be moved into the Thompson dock for the final touches.
As well as that, you're going to paint the ship and you're going to give it its final bits of plumbings and electrics. So Titanic is in the Thompson dock for about 6 weeks.
And now all the finishing touches are made. This includes the installation of the 3 enormous propellers.
The 2 molded steel side shafts weighed 38 tons each. The blades of the propellers were carefully bolted to the boss. The central shaft of the turbine was completely different and very modern. This work of art was a single piece made of a manganese bronze alloy. Installing these shafts was the last challenge facing the builders.
Putting the propellers in place was just as delicate as anything else, if not more so, because there's very little space and you now have a complete ship which you don't want to damage.
April 1st, 1912, the Titanic was preparing for its initial sea trial. A feeling of pride flooded the hearts of the men who had given 3 years of their lives to build this incredible ship. It was a testament to the ingenuity and expertise of everyone involved in the project.
Titanic sea trials are a moment of truth. They need to demonstrate that the ship is fit and seaworthy in all important respects.
On April 1st, the Titanic was supposed to start its trial, but unfortunately, the winds were too high to test the ship properly, so the trials were pushed back by a day.
Just one more delay that would seal the Titanic's destiny as one in a long line of ill-fated ships. But on April 2nd, the weather conditions were optimal. The giant of the seas could finally begin its trial.
It's the first time that the engines of the ship have turned, so it's kind of a grit your teeth moment to make sure that everything is lining up.
It's a feeling of pride and accomplishment for Harlan and Wolff, and there is every prospect that she has a successful and profitable career ahead of her.
And from there, Titanic steams down the coast, heading towards Southampton and her date with destiny.
The day after the trials, on April 3rd, 1912, the Titanic reached Southampton in southern England. It was here that the first passengers of the maiden voyage would board the ship a week later. Inside the ocean liner, the job wasn't finished yet. Many workers were hurrying to make final adjustments before the ship's departure.
There's still bits which need painting. Some cabins aren't quite complete. The heating system in a few second-class cabins ultimately leads to complaints because it's not particularly reliable.
You had to go through and make sure all these things are in place, and if there were any last-minute issues with carpeting that had to be finished being laid, overall just, doing all the touch-up.
Wednesday, April 10th, 1912, the day of departure. The event was celebrated with great pomp by the international media. The Titanic, heavier than the Olympic, was at the top of the podium. It was the single largest ocean liner in the world.
Every kid in Southampton skipped school so they could go down and get somewhere near the dock and watch the ship sail.
As passengers board Titanic at Southampton, there are some concerns lest anything would go wrong with a new ship. But as a crewman said, God himself cannot sink this ship.
The first passengers finally got a peek at this floating palace. The Titanic was unlike any ship ever built before. Its refinement pushed the limits to the extreme. Even the third-class passengers had never seen anything like it.
The passengers had electric elevators, along with very luxurious and comfortable lounges.
You have all of these different provisions to make Titanic a stay on board like being in the finest hotel in the world.
Imagine being on a mission to Mars or something. That'd be the closest thing we can come to today.
12:15 p.m. on Wednesday, April 10th, 1912, the Titanic weighed anchor at the port of Southampton, a day that would go down in history. 5 tugboats escorted away from the dock this Titan, the crown jewel of commercial sailing and pride of the White Star Line and of the Harland and Wolff shipyards. But the event nearly turned into a nightmare.
And as Titanic is passing along the line of moored ships, the suction from her engines, just as with Olympic and Hawke, grabs at the liner New York. New York's mooring ropes split and the ship drifts towards Titanic. There's almost a collision. Smith jumps in, orders full astern on the port engine. They stop with mere yards to go. Not an auspicious start to the maiden voyage.
As it turns out, the New York was the second-to-last obstacle and final warning of the tragic fate that would await the Titanic.
The Titanic, legendary, unsinkable passenger liner and the greatest disaster in maritime history. How did the sturdiest ship of her day sink in just a few hours on that fateful night in April 1912?
There is no single reason for the sinking of Titanic. It was a chain of events, a succession of errors or bad luck.
We all know the expression to be in the wrong place at the wrong time. It was a very particular set of circumstances which led Titanic to crash into that iceberg. It really is quite incredible.
There's this whole philosophical concept of the vanities of man. We were going to build this thing that can never be destroyed, and then nature answers differently.
Her tragic story was brought to life in the global blockbuster by American director James Cameron. Though the film stays mainly true to the facts, certain scenes take more liberal historical license.
She can stay afloat with the first 4 compartments breached, but not 5. Not 5.
Obviously, there was a film that was made that really brought it to the forefront of people's minds.
Like a film, let's rewind and perhaps change the ending. We'll reveal step by step every decision which could have helped avert the disaster. What if Titanic had changed route? If different choices had been made during construction? Or if the captain himself had acted differently?
One of the greatest myths, as far as Titanic is concerned, is what the iceberg actually did.
I think that the materials played a role in the sinking.
There was a succession of errors, and in my opinion, this was at least partly because the captain did not react appropriately.
Meteorological and atmospheric conditions played an essential role within the incredible set of circumstances that led to Titanic colliding with an iceberg.
World-renowned Titanic experts investigate and share the incredible story of a tragedy that should never have occurred. Among them is French diver and explorer Paul-Henri Nargeolet, whom we interviewed just weeks before he died aboard OceanGate's Titan submersible on its way to visit the Titanic's wreckage. Join us as we rediscover the Titanic and the events leading up to the disaster. April 14th, 1912. Titanic has a date with history. It's 48 hours until the start of her maiden voyage to New York. The world's eyes are fixed on this ocean giant, a showcase for Irish engineering and the pride of those who designed her.
Absolutely, Titanic at the time was very impressive. It was the largest ship of its kind.
The vessel Titanic was a culmination of the best technology in shipbuilding for its time.
The Titanic, when it was built, was the largest man-made moving object.
They really considered it looking like a hotel.
It was considered unsinkable.
The voyage was to be a triumph, and yet it turned into a nightmare. On her fourth day at sea, this great steel giant hit an iceberg and sank in under 3 hours, taking with her close to 1,500 people. The disaster made headlines, sending shockwaves around the world.
When word got back to the States, that was front page news for a lot of reasons, mostly because there was this notion that not even God can sink this ship. The whole Titanic story is a great example of the triumphs of humanity and technology, also the great disaster of humanity with the sinking of it.
How did the greatest ship in the world end up meeting such a dramatic end? 2 separate inquiries were immediately launched to shed light on the reasons for the disaster, except that all they had to go on were witness statements from survivors.
Even though there were witnesses that said that they saw the ship break in half, people still, for some reason, thought that the ship sank intact.
There's still mysteries, there's still contradictions, and there are little bits of information which don't quite fit.
The survivors' witness statements were far from conclusive. Many questions remained unanswered. Could the catastrophe have been avoided? Could Titanic have stayed afloat? And could every single passenger have been saved? There was only one way to find out. As in any criminal case, investigators were missing the material proof that would allow them to corroborate or not the survivors' statements. Only the wreck of Titanic could help them understand what really happened on that fatal night. But in 1912, it was inaccessible. What they did know was that it was 12,500 feet underwater, and at the time, there was no way of traveling to such great depths.
I've heard it told from the oceanographers that we work with that it is as complicated as sending a man or woman to the moon, just because of the pressure that's at the wreck site. It is 100% dark, the light doesn't get down there.
It wasn't until 70 years later that the miracle of technological progress partnered with a generation of pioneering deep-sea explorers that a solution to the impossible was found. The team rose to the extraordinary challenge of plunging into the abyss. In the space of a few decades, the wreck of Titanic had become the holy grail for every modern-day deep-sea adventurer.
There's very few human-occupied vehicles that can dive to 4,000 meters underwater, where you've got pressures of around 6,000 to 7,000 pounds per square inch pushing on the submersible from all directions.
In the summer of 1985, all hopes were pinned on a Franco-American expedition. But for the first 2 months, scientists found nothing.
I saw some wreckage that was obviously from a vessel, and that density of wreckage that we started to come into kept getting greater and greater and greater. And I know that we were all excited.
In the observation room, everyone held their breath. As the little submersible got closer to the wreck, the camera began to reveal scenes that had never been seen before. It was a historic moment. At a depth of 12,500 feet, there lay the object of months of tireless searching on the ocean floor. William and his team's dream had finally come true. They had just discovered Titanic's shipwreck.
The discovery of Titanic's wreck is a major stepping point as far as Titanic's history is concerned. Firstly, of course, it's a massive resurgence of interest, and it sparks this new wave of enthusiasm towards the story and finding out what happened.
Anyone on the ship ever could have predicted the reaction the world had to knowing that Titanic had been found. And that's what was the amazing thing, and it still affects me today, is that to us it was one thing, but to the world it was something much, much bigger and greater.
73 years on from the disaster, this incredible discovery led to the reopening of the inquiry into this tragic maritime accident and helped to finally reveal the answer to the question, could the disaster have been avoided? A detailed analysis of the wreck helped to provide an understanding of what happened aboard Titanic on her maiden voyage. And the revelations are spine-chilling. Firstly, well before the collision, a succession of human errors, exceptional meteorological conditions, and onboard incidents had already set the liner on road to ruin. Next, despite the iceberg's impact, the ship could have stayed afloat if different choices had been made. And finally, it would have been possible to have saved more people during the evacuation process.
There is no single reason for the sinking of Titanic. It was a chain of events, a succession of errors, or bad luck.
To understand what pushed Titanic to the depths, we must travel back to the day of her departure. April 10th, 1912, 4 days before disaster strikes. At Southampton Docks, it was a day of celebration. The biggest ship ever to be built was embarking on her maiden voyage from Europe to the United States. She was due to dock into New York 7 days later.
Titanic left Southampton, took on passengers at Cherbourg and then in Queenstown. After Titanic left Ireland, she encountered good weather and calm seas.
As Titanic starts her maiden voyage, crew are starting to get into the regular routines of shipboard life. Passengers are getting used to going around such a large vessel. And there's a very positive, relaxed, enjoyed atmosphere on board.
Everything may have looked like it was going smoothly aboard Titanic, but none of the passengers were aware of the drama unfolding in the coal bunkers beneath them.
For all the optimism going on above decks, there was a slight problem. It's not known exactly when it started, believed to be in Belfast, but one of Titanic's coal bunkers was on fire.
A fire had started in Titanic's hold. Not a fire with flames, but the kind that develops from coal dust that miners know all about. It's very dangerous and extremely flammable.
Could this fire, which started precisely in coal bunker number 6, have led to the sinking of Titanic? Could the fire have damaged the ship's structure? According to some experts, the fire was inconsequential.
Of the fire, there have been claims, of course, not only that it affected the bulkhead, but it affected the hull itself. There is no actual evidence of this. It's unfortunate that there was this fire, but it was very much a red herring in looking for the causes of the disaster.
Despite scientific confirmation, there is still doubt surrounding the consequences of the fire inside Titanic's hull.
Some people would say that that fire raised the temperature of the steel and it could have weakened the wall of one of those bulkheads and resulted in those boiler rooms opening up and water passing through.
The fact remains, despite the fire in the coal bunkers, the shipping company White Star Line deemed postponing the departure unnecessary.
This was perfectly ordinary for the time. The weight and heat of coal as it sat in the bunkers, coupled with humidity down there, often caused spontaneous combustion of coal. And while it was an inconvenience, it happened all the time.
This decision may appear contentious, but it was just the first in a long line of events which could have helped avoid catastrophe. Daytime, April 14th, 1912, 12 hours before disaster strikes. Up until this point, the journey had gone smoothly. The ship was even expected to arrive in New York a day early.
It was a successful voyage. Each day her speed was being gradually increased. Passengers commented on the comfort of the ship and the relative lack of vibration. As the voyage went on, people were having a good time.
But this was without taking into account the most formidable threat any ship faced in the North Atlantic Ocean: icebergs.
As the Arctic winter subsides in January, February, things start to warm up. You have Greenland on one side and Baffin Island on the other, both of which are home to glaciers. These glaciers start to break apart, fall into the sea, and float southwards, forming icebergs. It's a normal, regular process which happens frequently, regularly. It's the return of spring in the Arctic.
As they float south in the freezing waters, these giant blocks of ice inevitably fall into the path of transatlantic ships. Titanic was going to have to travel through this zone at the worst time of the year, a few weeks before or after, and the catastrophe would have never occurred. The week-long delays accumulated during the construction period and the inevitable presence of icebergs at the time of year sealed her fate forever.
When you look at maps of iceberg locations, there's absolutely nothing unusual about finding them off the coast of Newfoundland in April.
How could Titanic have hit an iceberg? At the time, the only way of locating them was with the human eye. The North Atlantic Ocean was a giant motorway regularly navigated by hundreds of ships. 10 years previously, ships had begun to be fitted with a new technology which had revolutionized the shipping industry. It allowed them to communicate important information to one another, such as the presence of these giant ice flotillas. This new technology was radiotelegraphy.
The radio had been introduced. This enabled ships to communicate when they're at sea, and over several years it became standard equipment on all of the major North Atlantic liners.
People were starting to use it to send warnings and that sort of thing.
This was one of the things which had really reduced the number of iceberg collisions in previous years and was a major advance.
In 1912, Titanic was equipped with the very latest in radio technology. It had a range of 400 miles, making it the most powerful in the world. And on April 14, 1912, between 9 a.m. and 11 p.m., radio operators had received several dozen alerts.
As Titanic steams on, radio messages of ice warnings start to come in, ultimately from 14 different ships.
These messages included information about the ice that was ahead. Titanic's captain and officers were well aware that they were heading into an ice zone.
At this point, Titanic's fate was not yet sealed. But unfortunately, one man's decisions were about to change that. Titanic's captain was Commander Edward John Smith. Age 62, he was the world's most seasoned seaman.
Is Captain Edward John Smith, a man with 49 years' experience at sea. He'd risen through the ranks and was one of the highest paid mariners in the world.
Before Titanic, he'd captained 16 ships owned by White Star Line. This was someone with a reputation for keeping his cool, for his temperance, who was very well liked by passengers and crew alike.
It was his final voyage, because upon arrival in New York, he was due to start his retirement, so he wasn't even coming back.
When this experienced captain received the ice warnings, he naturally changed the ship's trajectory.
He rerouted slightly southwards, which would extend the journey a little.
But was that decision enough? Crossing that zone was like moving through a minefield. As the sun began to set on April 14, 1912, other ships located in the same area as Titanic decided to halt and wait for daylight, aware of the danger these icebergs represented.
Californian was the closest ship as the crow flies, and in terms of miles, roughly 20 miles from Titanic, and she had turned her engines off on the far side of the ice field.
Unfortunately for Titanic and her 2,200 passengers and crew members, Captain Smith did not make the same decision.
He knew there was an ice field ahead, and he knew the temperature had dropped and they needed to be on their guard. And yet, Titanic did not reduce speed.
When you receive telegrams telling you there are icebergs everywhere, if you don't do anything, then there's some kind of problem. At the very least, you reduce your speed.
This terrible decision brought Titanic ever closer to her tragic fate, but this human error needn't have occurred. Despite his many years of experience, Captain Smith was overconfident and his decisions had grave consequences. 11 p.m. The ship continues through the icy waters of the North Atlantic Ocean at a rate of 22 knots, or over 24 miles an hour. Captain Smith did not know it yet, but what would soon have been the crowning moment of his career was about to become the greatest fiasco in maritime history, sending him and 1,500 passengers to their deaths. Despite this human error, at that moment the catastrophe could still have been avoided. That is, until a new factor became a part of the equation. Much harder to predict, it would lead Titanic straight towards the iceberg.
We all know the expression to be in the wrong place at the wrong time. It was a very particular set of circumstances which led Titanic to crash into the iceberg.
11:30 p.m., 10 minutes before impact. As was his custom, Captain Smith went to bed, leaving his second-in-command in charge of the bridge.
When Smith retired for the night, he ordered, quote, to be woken if it becomes at all doubtful. So he's very much on standby. And of course the officers take this seriously as well.
Both men were relying on the people with the most important job on board a ship in the middle of the night, the lookouts. Perched in the crow's nest at the front of the ship, these two men were Titanic's eyes. The safety of the entire ship rested upon their shoulders. Except that on the night of April 14, 1912, the situation was suboptimal.
The ship was at the center of a vast anticyclone. The weather was therefore extremely calm. The waters were still. No wind, no clouds, no rain, no storm. And there was no moon either.
On moonless nights, when the sea is calm, you cannot see the edges at the bottom of an iceberg. Usually you can see the white fringe around the bottom of an iceberg, but not that night.
Worse still, the lookouts lacked one essential item: binoculars. At the time, these were a lookout's principal means of watching the horizon at night. But unfortunately, they were inaccessible, and Captain Smith was well aware of this. A few days earlier, he had made a decision that turned out to have very serious consequences.
As preparations develop for Titanic's maiden voyage, Smith orders a reshuffle of officers.
A few hours before their departure from Southampton, one of Titanic's officers, a certain David Blair, was dismissed by the captain. This surprising decision had one major consequence, which was that unwittingly, David Blair did not leave empty-handed.
Now, as Blair departs Titanic, unfortunately, he unwittingly takes with him a small key. It's to a locker for the crow's nest, and it's believed that this locker contained the lookout's binoculars.
Could these binoculars have helped to avoid the collision? During the inquiry carried out directly after the disaster, Frederick Fleet, one of Titanic's lookouts, was asked this very question.
Frederick Fleet at the inquiry went so far as to say, if I had had binoculars, I might have seen the iceberg.
Was that true? It's hard to know for sure, but if it was, it would be awful to think such a tiny oversight could result in such a grand-scale disaster. "11:38 p.m. Titanic was advancing in the total darkness at a speed of 21 knots, just over 24 miles per hour. The surface of the water was completely still, when suddenly, the two men in the crow's nest saw a dark shape in front of them.
They ring the ship's bell 3 times, and they pick up the phone to the bridge. 6th officer answers. What did you see? Iceberg right ahead. Thank you.
When the lookouts see the iceberg, it's 500 meters away. Titanic was 250 meters long, so if we count in Titanics, the iceberg was 2 Titanics away from Titanic.
500 meters was the fateful distance that separated the ship from the worst obstacle she could have encountered on her journey. 11:39 p.m. William Murdoch, the ship's second-in-command, had no choice but to rise to the challenge looming ahead of him. He had to make a crucial decision in order to avoid hitting the iceberg head-on. There was no time to reflect. He had to act fast. According to James Cameron's film, he ordered the ship to be put into reverse. But that's not what really happened. Cameron took certain liberties with the script to serve his storyline, but standard procedure, as well as witnesses on the bridge, indicate that the engines were shut down rather than put into reverse. This is what really happened.
Murdoch orders hard starboard on the wheel, runs to the engine telegraphs and orders all stop.
A ship the size of Titanic doesn't turn on a dime. It doesn't stop very, very quickly.
Titanic very slowly starts to move to port.
The ship started to turn, but not enough.
They were going too fast. It was too late to start turning.
Unfortunately, by that time, the collision was unavoidable.
11:40 p.m. At the surface, it seemed Titanic could make it round the huge ice mountain. But underwater, a collision was unavoidable.
The berg comes into contact with her starboard bow, and tons of ice fall onto her well deck.
At that moment, the majority of passengers were unaware of the collision and the terrible tragedy that would follow.
A few people did feel it a little more than the others. They felt a slight sway. They saw in their whiskey glasses that the boat was tilting a little. But many people didn't notice anything at all.
What was happening beneath Titanic's waterline? Was her hull robust enough to withstand such an impact? To find out, we must go back 3 years earlier to the shipyard in Belfast. It was here, in Harland & Wolff's world-renowned shipyard, that Titanic was built. No expense was spared in order to ensure she would be the safest ship the world had ever seen.
The priority really was passenger safety.
The ship's keel was laid, and the shipbuilders then proceeded to construct the double bottom. And this was an enormously strong structure. In fact, the double bottom was so deep that a man could walk the double bottom without having to stoop.
This double bottom was unique. It provided her with an extra shield to protect against every ship's biggest threat, flooding. Were there to be a collision at the bottom of the hull, this revolutionary system would stop water flooding the interior of the rest of the boat. And Titanic's designers had even gone one step further in the name of safety.
From there, 366-foot tall frames are added, creating the main skeleton of the ship.
This metallic juggernaut skeleton was then covered in the most solid and the most robust material available. More than 2,000 steel plates from world-class Scottish and Irish steelmakers covered this colossal vessel to guarantee total resistance.
So Harland & Wolff use the best materials. There's no monetary limit. And so the metalwork used was the best available for the time.
But on April 14th, 1912, would this newly built ship withstand the pressure of an iceberg? Or on the contrary, would it sound the death knell for this ocean colossus, revealing her to be nothing more than a giant with feet of clay?
One of the greatest myths, as far as Titanic is concerned, is what the iceberg actually did. Now, the newspapers of the day reasoned that for an unsinkable ship to sink, it had to be massive. And images of the period depicted this great tin opener tear alongside a third of the ship.
If you believe the film script, then at the point of collision, the iceberg slashed like a dagger through the steel plates covering Titanic's hull. So was it this huge gash that sunk the ship? The full story didn't come out until 84 years after Titanic sank during an exploration of the wreck. What it revealed suggests that despite the brutal impact of the iceberg, catastrophe could once again still have been avoided. July 1996, the site of Titanic's demise. A headlining scientific expedition to explore the ship's ruins is in preparation. The aim is to inspect the wreck at the point of impact with the iceberg. The idea was to find an answer to the crucial question that still kept this legendary ship shrouded in mystery. What was the damage caused by the iceberg's impact?
Once the Titanic was discovered and once we started doing expeditions, we started understanding more and more about how the impossible did in fact happen.
But it was a devilishly complex task. When Titanic hit the bottom of the ocean at a speed of 38 miles per hour, her prow became buried deep in the seabed under a 10-meter deep layer of sediment.
When the prow hit the bottom, it was buried in the sediment, like the tip of an arrow. It pushed and pushed and pushed until there was enough resistance for the whole thing to come to a halt. So the prow got buried, and this mountain of sediment rose up in front of it. So the idea was to use a drilling sonar probe, which would let us see past the sediment to what was behind it.
But to use this probe, they needed to go down to the shipwreck at a depth of 12,500 feet. At the time, there were only 3 submarines in the world capable of doing that, one of which was built in France, the Nautilus. This little submersible, designed by the French Research Institute for Exploration of the Sea, has some unusual capabilities. Frenchman Paul-Henri Nagelet, one of the Titanic shipwreck's most renowned experts, led the team aboard the Nautilus.
The Nautilus is a submarine designed for scientific exploration, which consists of a titanium sphere with a 2-meter interior diameter, which is actually quite big for this sort of submarine. And on the sphere are 3 portholes in triangular formation, 2 looking down and 1 looking up. There are lots of cameras to record everything, and searchlights, of course, because you're in complete darkness, so you absolutely need searchlights.
So for years, we could only speculate about the damage on the hull. And in 1996 was the first opportunity to begin to see the damage that we always thought was a 300-foot-long gash.
The inquiry had concluded there was a 300-foot gash along the hull, and so the ship had sunk in an hour and a half. But that doesn't make sense.
Paul-Henri Nagelet can be certain of this because the evidence collected by the probe is incontestable.
We realized that actually there were probably 6 gashes that were not all at the same height. It's as though the iceberg had left claw marks in the hull.
Relatively speaking, the damage from the iceberg was quite small.
The average height of each of these splits is barely 1 inch. Hardly the gash that the popular press had predicted.
The iceberg had therefore not gouged the ship in any serious way. The steel had held fast. Put the 6 splits together and they'd create a hole the size of a front door, negligible for a ship on the scale of Titanic.
It wasn't a big gash, it wasn't a huge hole in the side of the ship. It was a very narrow opening that went on for a long distance. And that opening was caused by the plates buckling.
Put simply, the steel plates covering the hull of Titanic buckled under the iceberg's impact. But the splits were located at the most fragile points of construction, the joints between the plates. The quality of the steel was therefore no longer in doubt. The focus was now on the rivets at the joints.
We could see evidence of empty rivet holes that suggested it was a seam that opened and not the fracture of a plate that we had originally thought years prior.
This analysis confirmed it was the rivets that broke under the force of the impact. And this begs new questions. Were they strong enough? Were they built to withstand such an impact? And above all, had they been properly screwed in? To find out, we need to return again to 1909 and to Harland & Wolff's shipyard in Belfast. In 1909, rivets were a fundamental element of shipbuilding. They may be small, but they played a major role in ensuring a ship was watertight. Building Titanic required a colossal 3 million rivets.
At the time, in shipbuilding, in bridges and other structures, riveting was the way that you held those plates together.
Fitting them was a huge challenge. They had always been fitted by hand by a team of riveters in which each person had a very precise role.
How the plates would have been assembled is they would have been prepared in place with pre-driven holes. Then you'd have a hot rivet that would be thrown up on the structure, straight off a fire, pass through the hole, and you'd have 2 men who would hammer alternately to form the second head. And then as it would cool, it would shrink and hold the plates together.
These shipbuilding experts only had a few seconds to fix each rivet in place to ensure each one was fully watertight. One wrong move and the ship would no longer be safe from flooding. To ensure efficient progress, Titanic's shipyard was using a new invention, the height of modern technology, a hydraulic riveter.
The difference was that they were beginning to use machines to rivet more consistently and more quickly. It was like 12 times quicker to use a machine than do it by hand.
The U-shaped machine was at the cutting edge of technology and provided users with a double advantage. Not only did it considerably speed up the pace of construction, it also used rivets made of a material that was less fragile than the usual wrought iron: steel.
This is using steel rivets rather than wrought iron. They are slightly stronger, they can be fitted more quickly. This is something which speeds up construction and gives a stronger, more stout frame to the vessel.
But this revolutionary tool also had its limits. Firstly, it was difficult to find enough laborers qualified to use the new hydraulic riveters. Secondly, these enormous machines were hard to maneuver, especially in the more cramped parts of the shipyard.
In the bow and the stern, in the ends of the ship, it's very tight and it's difficult to move these very large machines through the gantry.
To facilitate the riveting and to keep up the pace of construction, White Star Line made a decision, the consequence of which they did not foresee. It was a decision which indicates once again that the catastrophe could have been avoided. They decided to use 2 different types of rivet. The center of the ship, the most fragile section subject to the greatest amount of stress during a voyage, was built using these robust steel rivets and a hydraulic riveter. But the steel sheets at the prow and the stern were treated differently.
The bow and the stern were the areas that were riveted with iron. partly because it's tight spaces, you need someone to do this by hand, and the riveters liked working with iron. It was faster, it was less expensive.
This choice inevitably begs the question, would the rivets at the prow of Titanic have withstood the iceberg's impact if they had been made from steel instead of wrought iron? To find the answer, further exploration of the wreckage was required in a mission that was only made possible 86 years after the sinking of Titanic. August 10th, 1998. A landmark day in Titanic's history. Paul-Henri Nargeolet and his team were about to breach limits of technology in order to assess the ship's structure. The French explorer was well aware that this type of mission, 12,500 feet down, had a time limit and that the risk of accident was multiplied exponentially at such depths. He had been tasked with one of the biggest challenges in the history of deep-sea exploration: to collect and return to the surface a fragment of the hull of the most famous shipwreck in the world.
We started looking for a piece that wasn't too enormous down there because we found some pieces and I was looking at them and thinking, that weighs at least 200 tons. No way we can bring that back up.
After a detailed exploration of the sea, Paul-Henri Nargeolet located the perfect fragment. A 20-ton section, equivalent in weight to a semi-trailer with a surface of 280 square feet. It wasn't a section of the prow hit by the iceberg. It was a piece of the starboard section of the hull, located at first-class cabin level. This piece was more easily accessible, and studying it would reveal the answers to several rivet-related questions.
The advantage of this piece was that it had a lot of rivets and it had portholes. It was very representative of the ship's construction process as a whole.
It was the first time in the history of humanity that such a feat had been carried out. This fragment of the hull from the most famous ship in history was the missing link in a so far impossible investigation. But there was more to come. During the same expedition, the deep-sea experts also unbelievably managed to collect some of the wrought iron rivets near the prow of the wreck. Would this evidence help to reveal if the secrets of Titanic's construction had played a part in the disaster? Could they be used to work out if the tragedy could have been avoided if different construction choices had been made?
Before some of the forensic and scientific expeditions had been conducted at Titanic, there were many, many theories about imperfect metal being used, poor quality steel.
Where did the truth lie? Jennifer Hooper is an expert in metallurgy. She had made it her personal aim to solve the mystery. Finally, she could measure the quality of these little joints. What she discovered was beyond anything she could have imagined.
In the end, any ship may have sank as a result of that collision. What we want to do is really and truly understand, given what was considered state of the art, what role did it play?
(1999), Johns Hopkins University, Baltimore, United States. Jennifer Hooper's thesis focused on Titanic's rivets, particularly those made of wrought iron at the prow, where the collision occurred. She wanted to know their precise level of resistance.
We used microscopes to look at the surface and look at the composition. We also did mechanical testing to try to understand how strong and tough those rivets and the rivet material was. We also did computer modeling to simulate collisions that would force those rivets to break, so we could analyze all those different things.
This detailed inspection revealed the presence of slag. This solid residue, which looks like tiny stones, is a result of the fusion of metallic minerals. Its presence is completely normal. What was less normal was its level of concentration.
When you compare the iron in the Titanic to other material like that, you see very large pieces of slag. That indicates that it was not sufficiently worked.
According to the American researcher, the acceptable quantity of slag in a wrought iron rivet at the time was a maximum 3% of the composition of the piece. But when she examined some of the rivets used to fix the steel sheets to the ship's prow, she noticed abnormally high levels of slag. Some rivets were composed of up to 40% slag.
We were seeing very large particles, and the reason that's important is because under high stress or strain, those particles can cause weakness. So it's not really a question of whether it would have sank, it was really just how fast.
But could the rivets have more easily withstood the impact if the slag percentage had been lower? As far as the experts are concerned, without a doubt.
It was kind of what was expected at the time. There's some variability in it. But again, the ship was designed very well and would have met today's standards for a passenger liner.
Titanic's structure was at the height of technological progress and highly capable of containing a flood, not just because of her double bottom, of course, but also because of the hull's interior skeleton, which was divided into 16 separate compartments via 15 watertight partitions.
The partitions were a relatively new feature of shipbuilding, and Titanic had a large number of them. She had been very well designed.
To ensure she remained completely watertight, these sliding doors needed to be closed. They could be locked remotely via a switch, or thanks to a simple automatic detection system using a float.
So in case of an accident or an emergency, the bridge could close those watertight doors and keep water from one watertight compartment from getting into another watertight compartment.
Thus, if one of the compartments flooded, it could be completely cut off from the others to avoid the flood spreading. Thanks to this amazing feat of technology, Titanic was able to stay afloat with up to 4 flooded compartments.
Most other ships' 2 compartments would sink it. So this was unparalleled with the amount of safety, the amount which could potentially be damaged, and the ship would survive.
11:50 p.m. Captain Smith sends Thomas Andrews, the ship's architect, to urgently check the damage to the ship's compartments. The man knew every nook and cranny of his ship. For him, she was the pinnacle of his young and brilliant career, still so full of promise. And yet, that night his dreams of glory were suddenly over. When he inspected the compartments, there was no doubt.
He's later seen, very shortly after this, going up the grand staircase, ignoring passengers, which was unusual for him, taking the steps 3 at a time, and was described as having a look of absolute terror on his face.
The news felt unreal. The world's first truly unsinkable ship was going to sink in the North Atlantic Ocean on her maiden voyage. Here, in James Cameron's celebrated film, Thomas Andrews, played here by actor Victor Garber, explains why.
She can stay afloat with the first 4 compartments breached, but not 5. Not 5.
Except that's not entirely accurate. The collision damaged the rivets of 6 compartments, not 5.
5 compartments were open. The 6th was also taking in a minor amount of water.
The reality was that too many compartments were flooded. In such conditions, Titanic's ultra-modern watertight system was useless.
Think of it like a whole bunch of cups, and that when one fills up, it starts going, the water keeps coming in that one, but it goes and starts filling into the next cup.
Despite the design of the watertight compartment, Titanic simply experienced flooding that she was not designed to handle.
There was no way of counteracting that amount of water, and the sheer weight would ultimately take her to the bottom.
12:05 p.m., 25 minutes since Titanic hit the iceberg. Catastrophe was now unavoidable. An unsinkable ship was going to sink. However, it was still possible to save the lives of the 2,200 passengers and crew members. Californian, a ship which halted her crossing due to the large number of icebergs reported on her route, was close to the troubled passenger liner.
Californian was the closest ship as the crow flies, and in actual miles, less than 20 miles away from Titanic. And she had turned off her engines on the far side of the ice field.
The evidence is that Californian was in visual distance of the sinking Titanic.
But luck was not on Titanic's side. At that moment, her many Mayday messages sent out by radio had gone unanswered. So what was going on aboard Californian?
Californian had turned off her radio at 11:23 p.m. It wasn't compulsory to keep a radio operator on call. Titanic hit the iceberg at 11:40 p.m. If it had been just 10 minutes earlier, Californian may well have heard Titanic's distress signal.
If Californian's radio operator had stayed on duty, there's every chance that he would have heard Titanic's distress messages.
10 minutes earlier, and Californian's radio operator could have transmitted the distress signal. Without realizing it, he had condemned a large number of Titanic's passengers to certain death. 12:55 p.m. Titanic has been taking on water for an hour and 15 minutes. By this stage, everyone on board the ship was aware she was going to sink and that the lifeboats were the only way to survive.
As time went on, the passengers became more panicked. Crew members managed the stress in various ways. Some made use of their firearm to reestablish order.
4:10 a.m. The people in the water had frozen to death. The survivors in the lifeboats were attempting to stay warm. Then suddenly, a ship appeared, Carpathia.
Carpathia arrived about 2 hours after Titanic had disappeared. So it was an anxious wait for people in the lifeboats. They were anxiously waiting for help to arrive.
Though she was further away than Californian, she had received Titanic's distress signals and had redoubled her efforts despite the presence of icebergs to come to her rescue as quickly as possible.
The priority was to bring in all the lifeboats and get everyone on board to warm them up, since they had spent several hours in the lifeboats on a freezing night.
Of Titanic's 2,200 passengers and crew members, only 1,178 of them could have been saved on the lifeboats. But the actual loss of human life was much higher. 1,500 people died in the freezing waters of the Atlantic, including Captain Smith and architect Thomas Andrews. With only 711 survivors, this shipwreck is the most terrible in maritime history, giving the story of Titanic legendary status. Despite the human errors which led to her sinking, Titanic remains a technological feat of her time which became embroiled in a tragic chain of events.
There were certain elements which in themselves were not major, but put all of these individual chains together and you start to get a major incident. Take out any of those links and you could have prevented it.
There was a succession of errors, and I think it's partly down to the captain, who didn't react appropriately. He didn't act as he should have done.
It was really down to human as opposed to scientific error. Despite everything that was said about icebergs and mirages, the main reason was probably the ship's high speed.
Since that terrible night of April 14th, 1912, Titanic has become a monument of the depths. Her legendary status not only attracts professional researchers, wealthy tourists have recently been able to take in the privileged view of the wreck from inside a little submersible known as Titan, designed by American company OceanGate, until this commercial initiative became a monumental fiasco. On June 18th, 2023, this little submarine gave way to the pressure of the depths and imploded. 111 years after she sank, Titanic had claimed more victims. Among them was French explorer Paul-Henri Nargeolet, who died at the age of 77, just a few weeks after granting us his final interview. This man devoted his life to Titanic and played a huge role in the discovery of many of the elements that have helped advance the inquiry into the reasons for the disaster, enabling us to answer the question, could the disaster have been avoided?
The Titan. This small revolutionary submersible was developed by American company OceanGate to transport wealthy tourists to the world's most famous shipwreck, the Titanic.
The OceanGate Titanic experience. There's truly nothing else like it.
You dreamed about years, and now you are here. This was amazing.
Except that on June 18th, 2023, the adventure turned deadly. Less than 2 hours after its descent, the Titan vanished, with 5 people aboard. Over 4 days, the world held its breath in the hope of finding the passengers alive.
They're stuck in this tiny tin can at the bottom of the ocean, in the cold and in the dark.
I imagined that they were alive inside the submarine and how awful it would be if they weren't found.
It's a bit of a nightmare for everyone on board. You could compare it with the proverbial burying alive.
The terrifying countdown to the tragic ending captured international headlines. The world reeled when debris from the submersible was found near the wreck of the Titanic. What went wrong? Was the disaster caused by a design flaw? Or was it a matter of pilot error?
The submarine can get caught on cables or other parts of the wreck. You may be trapped.
A blackout. The submarine found itself with no electricity, no lights, no communications. That's when its journey to death and destruction began.
Now, through extraordinary archive materials and 3D reconstructions, we are going to recount the tragedy of the Titan and the various scenarios of its ill-fated, deadly descent. Interviews with experts, former passengers, and the victims' families will take you to the bottom of the greatest catastrophe in the history of underwater exploration. It is June 18th in the North Atlantic Ocean. 9:30 a.m. The icebreaker Polar Prince launches a small experimental submersible named Titan into the water.
Roger, platform ready to dive. We are in position.
In 2 hours' time, its 5 passengers have a rendezvous with the Titanic, and they have paid a handsome sum to have the rare privilege of beholding its wreck. Among them, 3 thrill-seeking tourists. Hamish Harding, an American pilot, along with Shahzada Dawood, a Pakistani businessman, and Suleiman, his 19-year-old son. Their tour guide is the world specialist on the Titanic, Frenchman Paul-Henri Narjolet.
If he was offered an expedition to the Titanic, that was his priority. It had always been his passion, and I thought it was a nice opportunity for him to go and see the Titanic once again.
Stockton Rush, the Titan's pilot and inventor, completes the crew. However, nothing predestined this millionaire's son to go and inspect the wreck of this famous ocean liner. Because initially, he wanted to become the first man to ever set foot on Mars. But despite having a degree in aerospace engineering under his belt, his dream abruptly came crashing down during a routine medical checkup.
He was found to have eyesight problems, then he came up against a lot of brick walls that he couldn't buy his way through, so he couldn't go to Mars.
So it was through this disappointment that Stockton Rush changed course. He turned to underwater exploration, and right away he set his sights high.
Stockton Rush was someone who very much wanted to be a pioneer in deep ocean technology.
What he wanted was to be recognized as some kind of Leonardo da Vinci of the deep sea. Little by little, he got this idea in his head, that of transforming the depths of the ocean in the same way that Elon Musk and Richard Branson had done with space into a tourist area.
In 2009, Stockton Rush founded OceanGate, a private company that wanted to offer a unique experience for tourists.
The OceanGate Titanic experience. There's truly nothing else like it.
Something never seen before.
He wanted to make his mark on history by creating an inexpensive, efficient submersible that anyone could pilot and which would allow people to visit the wreck of the Titanic and even other wrecks as well.
But to achieve that, he had to design a submersible that would be capable of taking the tourists down to a depth of 3,800 meters, 2.5 times the depth of the Grand Canyon. Another major constraint to take into consideration, the pressure of the depths. Because the final resting place of the Titanic is the most hostile environment on the planet, the abyss. The pressure exerted there is 380 kilos per square centimeter.
The analogy we use is that of a big elephant standing with all 4 feet on a can of soda.
It's just a staggering amount of pressure. It's like God's own hammer, hammering the material over and over again.
And to dive on the Titanic is very much like going into outer space.
And so therefore very few people have been there.
But that didn't stop Stockton Rush. After 10 years of work and the creation of a prototype, he arrived at the final version of this submersible, named Cyclops II. Following a set of encouraging tests, he decided to change its name.
They changed the name to the Titan.
It was mimicking the Titanic itself, which was claimed to be unsinkable.
Now, an old tradition in the sea is that it is always bad luck to rename a ship.
A bad omen for a pioneering submersible, designed to explore the most famous shipwreck site in the history of commercial sea travel. Approximately 7 meters long by 3 meters wide, the size of a tank, the Titan looked like most other small submarines already in existence. It was equipped with ballasts and weights, just like any other scientific submersible. But the comparisons end there, because Stockton Rush created a vessel that was radically different to anything that existed up until then.
Hi, my name is Stockton Rush. I'm the CEO and founder of OceanGate. Let's take a look at Titan. Best seat in the house. You can look out the viewport. We put a privacy screen in.
Surprisingly, inside there were very few instruments aboard.
We have our control screen here, our sonar screen here.
Compared to a conventional submersible, which has lots of screens, buttons, levers, and so on, there was hardly anything. It looked, to put it bluntly, like a can.
Its cylindrical form was unheard of. Every other exploration submarine has a spherical cabin, so that pressure is exerted evenly on the hull. But this innovation made the Titan the only submarine in the world capable of carrying 5 passengers to 3,800 meters under the water's surface.
5 people is a lot. You wouldn't think, but for a pocket-sized submarine, that's incredible.
To ensure its robustness, Stockton Rush equipped the Titan with a hull made of highly resistant materials. The 2 ends of the submersible were made out of titanium, a virtually indestructible component which had already proved its worth in the deepest depths of the globe. But the central section was made out of a very innovative material.
Stockton Rush chose a revolutionary material because it was light, easy to assemble, and inexpensive: carbon fiber. It is used in the aeronautical and aerospace industry. It has excellent properties, but had never been tested at such depths before.
Even more unconventional, this tourist submersible had a viewport with a diameter of 60 centimeters, 2 times bigger than an airliner. Once again, this was completely unheard of.
To entice the tourists and offer them an unforgettable experience, this viewport would allow them to see the Titanic and almost touch it. The promise of this totally incredible experience was the Titan's main selling point.
But that wasn't all. The Titan's steering controls were also surprising. The height of innovation, its 4 electric thrusters were maneuvered thanks to this accessory of incredible simplicity for such a vessel.
So if you want to go forward, you press forward. If you want to go back, you go back.
It was a video game controller, like one you'd find for commercial use.
And it's Bluetooth, so I can hand it to anybody. And it's meant for a 16-year-old to throw around.
And Stockton, he boasted about it. It was definitely a bit surprising because on the one hand, it was this revolutionary machine in many ways, and at the same time, there was this DIY MacGyver feel to it, with these objects that you or I could go out and buy.
And it was with this new generation submersible that Stockton Rush launched his project in 2021 with his company, OceanGate. His aim was to offer tourists the opportunity to contemplate the wreck of the most famous ocean liner in the world for the modest sum of $250,000, almost 230,000 euros. A fortune for mere mortals, but a formality for millionaires in search of extraordinary experiences.
Extreme tourism is really growing as a market. The idea of pushing the limits, ordinary people going to the very edges, Everest, space, Antarctica, the bottom of the ocean, the Titanic.
There are actually quite a lot of people who can afford to pay $250,000 to go underwater and see the wreck of the Titanic.
The Titan's first expeditions were a great success. Thanks to Stockton Rush's audacity, you no longer had to be a scientist to go and enjoy a sensational ride around the most mythical of shipwrecks.
Don't miss the opportunity to be part of history. The OceanGate Titanic experience. There's truly nothing else like it.
No one believed in Stockton Rush. When he succeeded in his crazy dream to reach the wreck of the Titanic with his little Titan, everyone shouted, "Wow, the man's a genius!"
Very quickly, the waiting list grew to go aboard what had become a phenomenon, the Titan. Hailing from Las Vegas, property developer Jay Bloom and his son Sean were tempted by the experience.
I'm a little bit of an adrenaline junkie. My son and I normally do a lot of these adventures together when possible.
It wasn't really like a dream or anything. It was more of a bucket list item. It was more like, oh, cool, like, let's go see the Titanic, you know?
Retired businessman, German millionaire Arthur Leubel is also a fan of extreme tourism activities. When he bought his place aboard the Titan, he was indulging himself in fulfilling his childhood dream.
They've also told me a lot about when I was a kid, and it's a mythos forever, I think.
In August 2021, he went on the experience. Arthur Leubel documented his dive in Titan and allows us to relive his descent, thanks to these exceptional archives.
When I was inside, you cannot stand. You're sitting 10.5 hours on the bottom. You say, close the Titan from outside.
Other submersibles always have the possibility of being opened from the inside in case of emergency, but not the Titan. The passengers therefore willingly accepted to be locked in by this unique procedure, leaving them at the mercy of an external intervention to get them out if there was any problem. Once it was completely locked shut, Titan was launched into the water. Placed on a floating pontoon, it sank a few meters below the surface. Then the submersible fired up its engines, and the experience began. A sensational dive to the depths of the ocean.
It's special, it's quiet, you hear nothing. You feel pressed and it's black outside, you know you cannot go out.
Throughout history, less than 60 people have had the privilege of experiencing the following moment. According to the information we have available to us, around 40 of them were able to do so thanks to Stockton Rush and his Titan.
Suddenly, you get to the bottom, the projectors light up because visibility is really poor, and in front of you, you discover the wreck of the Titanic.
Hundreds of tons are losing your body. You become happy. You dreamed about years. You paid a lot of money for this, and now you are here. This was amazing.
It is an absolute dream to be able to go down there and see that Grey Lady of the Atlantic in person.
And the show had only just begun. The Titan now sailed around the wreck, getting close up like never before. The extreme tourists needed to get their money's worth.
This wasn't a scientific expedition. The idea was that everyone would be thrilled. Getting close enough to practically touch the Titanic was all part of the experience.
So we have go 2 times around the Titanic, and 2 times we sitting on the deck.
Going over the bridge and seeing where the captain perished and seeing where the lifeboats had been sent into the ocean. And you can just in your own mind think of what it must have been like to be on the ship when it went down.
For me, I had the feeling I'm now live 1912 on board because PH was telling us everything.
More than just a guide, Paul-Henri Nargeolet was Mr. Titanic. The French explorer had dived down to the wreck almost 40 times as submarine pilot for IFREMER, the French National Institute for Ocean Science and Technology. Thanks to him, more than 5,000 objects from the ocean liner have been brought back up to the surface and keep the memory of the shipwreck alive.
The Titanic was like his big brother. That's how it was. Sometimes I was a little jealous because I said to myself, he prefers to spend more time with the Titanic than his family.
Paul-Henri Nargeolet couldn't have imagined that the wreck of the Titanic would become his tomb. Sunday, June 18th, 2023. It's 9:30 a.m. Back to the Titan with its 5 passengers on board.
Roger, platform, ready to dive.
In 2 hours' time, Stockton Rush, Paul-Henri Nargeolet, Hamish Harding, Shahzada, and Suleiman Dawood have a rendezvous with the Titanic.
They begin all the usual procedures. Everything seems perfectly ordinary. They've done this plenty of times before.
Number 1 requirement when you dive in a deep ocean submersible. There is one. You come back. Other than that, everything is secondary.
As the capsule closes, they don't know that their fate is sealed and that they have just signed their own death warrant.
Titan ultimately disappears beneath the waves. One person takes a photograph. It's a nice little souvenir, but nothing particularly remarkable. They're following the descent. And then suddenly there's silence. That's never a good thing.
1 3/4 hours into the dive, Polar Prince, the Titan's mothership, loses contact with the submersible. It's not the first time that this has happened. The OceanGate team on the boat tried to restore communication by all possible means.
Radio waves do not travel through water. So they're using acoustics, they're using transponders. Some of this is direct messaging. Communication has obviously gone wrong, so they're aware that something is up.
On the previous occasions when they had lost contact with the Titan, it had reappeared a few hours later. But after 8 hours without any sign of life coming from the submersible, something is up. There is growing concern.
That is a long amount of time which they're waiting, knowing that something is wrong, but unable to help.
The expedition team leaders have no other choice but to call for help and alert the Coast Guard. The news is immediately made public by the media. In just a few hours, Titan's name circles the globe.
Tonight, near the site of one of the 20th century's worst ocean disasters, a new undersea drama is unfolding.
Correm contra o tempo para encontrar o submarino que simplesmente desapareceu.
Ce petit sous-marin, il y avait 5 personnes à son bord.
Eksperymentalnej łodzi podwodnej Titan.
El Titan. Sí, Titan. Y otra cosa es que el sumergible.
Teams hätten mehrfach Klopfgeräusche.
A mí me gustaría, Antonio.
It was everywhere. It was inescapable. It was on every news channel. It was all over social media.
The eyes of the world were upon Titan. The world stopped.
Antoine là, embarquement direct de Washington. Alors, ce qu'on sait, c'est que ce sous-marin était en train de descendre vers l'épave du Titanic. Comme ça concerne le Titanic.
Being linked to the Titanic, it went global. Everyone was interested. There was even this on-screen countdown with the seconds, minutes, and hours ticking away, and people were glued to their screens.
Scotchés devant leur télé.
The faces of the Titan's 5 occupants were broadcast across the world. Sidonie Nargeolet is Paul-Henri Nargeolet's daughter. She remembers the moment when she heard the news.
It was completely surreal for me. I was telling myself it was my dad, and that nothing could happen to him. It was impossible.
What happened aboard the Titan? In the first few hours of its disappearance, many theories were flying around. Was it drifting somewhere on the surface? Or stuck at the bottom of the ocean? The entire planet was imagining the nightmare that its occupants would be going through if they were stuck in this little submersible in the middle of the North Atlantic Ocean.
If a submarine doesn't come up to the surface in 24 hours, then you have a problem. A big problem.
We're going to bring them back. You always have to have that hope. You don't give up.
After 8 hours without any news, there is still a real hope of finding them alive. But time is of the essence, because the 5 passengers have oxygen reserves to last them 4 days. That's 96 hours. If they aren't rescued by then, they could die of asphyxiation.
We are waiting, tick-tock, tick-tock, as the oxygen runs out, and we wait for some news from the Titan that doesn't come. These are all ingredients of a horror film. Actually, a scriptwriter could have written this film.
The clock is ticking down, and this is an absolutely immovable deadline.
Monday, June 19th. The Titan disappeared 24 hours ago. The U.S. Coast Guard is leading the rescue operation. At this point, there are many possibilities. The Titan could very well be stuck at the bottom of the ocean or have come back up to the surface with no way of communicating its position.
Much like an earthquake situation, speed is the utmost urgency. Those first few hours, the best opportunity to actually find people, to get them out okay.
American and Canadian military planes are patrolling above the ocean, trying to spot Titan on the ocean surface. Finding it is a huge challenge because the search area is gigantic.
20,000 square kilometers with a depth of 4,000 meters. It will be easier to find a grain of sand in a haystack. It's very, very difficult. They even asked airlines who were flying over the area to keep an eye out in case they saw the Titan on the surface.
It is white. If it was yellow or red, it would be easier to find, but that's not the case. With the white clouds and the foam of the waves, that makes it extremely hard to spot.
It's a Titanic mission, and its correct execution could have decisive consequences on the lives of the passengers. In this first scenario, they would be trapped inside the Titan, locked in from the outside, even though they can see daylight.
I was very afraid of them being alive, but of knowing coming to their rescue. I was scared, above all, that they would run out of oxygen.
But there is no trace of the Titan at the surface. In the meantime, the rescuers are attempting to probe the ocean depths in the area around the wreck of the Titanic. To do so, they have a formidable tool at their disposal, the sonar buoy. They act as the ears of the sea rescue team.
A sonar buoy is basically used to listen to what's happening beneath the sea's surface and to pick up sounds that could potentially detect the Titan.
These highly powerful military devices are capable of detecting sound within a radius of several kilometers. Rescuers drop these sonar buoys in the hope of finding a sign of life given off by the Titan and its occupants. But after a day's searching, there is still no trace of the submersible in distress. The morning of Tuesday, June 20th. The Titan only has 51 hours of oxygen remaining.
We imagine the anguish of these people who are trapped at the bottom of the ocean in this tiny vessel, who know that after 4 days, they'll have no more oxygen left.
45 hours after the loss of contact with the OceanGate submersible, ships finally arrive in the area after their long journey from the continent to try and locate the Titan. Coast Guard and military vessels, as well as civilian and industrial ships, have responded to the call for help.
People want to believe that this crew is alive. That is why everyone is so energized and also spending tens of millions of dollars to try and save the Titan's crew.
With so many searches, I said to myself, there has to be hope. People believe that we can find them and they are okay.
This rescue operation monopolizes news channels around the entire world. It's against this backdrop that one theory begins to gain traction. And the thought is terrifying. The Titan could be trapped in the wreck of the Titanic at a depth of 3,800 meters, with billions of cubic meters of water above their heads.
I dove on the Titanic in 2019, and I have no intention of going back. And I will say it was the most dangerous dive that I've ever done, because the currents can be unpredictable and push you into the wreck. The submarine can get caught on cables or other parts of the wreck. You may be trapped.
The possibility of such a scenario is chilling. But at the Coast Guard headquarters in Boston, it is being seriously considered. So how can they find out?
At that point, the rescuers are blind with no idea what's happening underneath the water.
There is no other option. They will have to dive down to the wreck of the Titanic to search for them. But for logistical reasons, that is no easy task.
There are so few manned submersibles that can go down to 4,000 meters. More like about, and most of them are not in operation any longer, and most were not in that location.
However, there is a solution: underwater robots.
Remotely operated vehicles, or ROVs. That's where you have a pilot looking through the camera in the ROV, piloting it, and it has manipulators so it can actually do things.
As luck would have it, two of them are available: the American rover, Odysseus 6K, and the French robot 6000 from Ifremer. However, they are far away from the search area. They are urgently transported to the North Atlantic Ocean. Their estimated arrival is Thursday at dawn, but time is running out. If the Titan's crew is still alive, they will have less than 4 hours of oxygen remaining by then.
When the robots get there, the rescuers will finally be able to see what's going on in the wreckage of the Titanic and then potentially find the Titan.
These sophisticated pieces of technology are the rescuers' best chance of finding Titan and its 5 passengers. Meanwhile, the U.S. Coast Guard holds a press conference from their headquarters in Boston.
Is a deep-sea rescue a realistic prospect? What would that look like?
Well, I can't tell you exactly what it would look like. I would tell you that, we are out there, we're searching and putting all effort out there.
Normally, Americans are always very optimistic, but not this time.
Despite an intensive 3-day search, the Titan can't be found. For their families, each hour that goes by without any news of their loved ones brings more heartbreak.
There were difficult moments when I thought, is it over? And then others when it was, no, you have to believe it might be okay.
Wednesday, June 21st. The Titan disappeared 3 days ago. If its 5 passengers are still alive at this stage, they have less than 20 hours of oxygen remaining. But just as all hope appears to be lost, there is some good news. One of the sonar buoys picks up a signal.
Noises start being heard, bangs coming from somewhere beneath the sea.
Muffled sounds, and above all, ones that are repeated every half an hour. And that points to these sounds potentially being made by humans.
While the Coast Guard attempts to formally identify the sounds, the experts highlight the presence of one man in particular aboard the Titan, Paul-Henri Nagelet. In such a critical situation, this formal naval officer and experienced diver is the man for the job. He could be behind such signals.
My father was always calm in a crisis situation. He was someone who didn't give up, who knew what he wanted and who could find the way to get there. We thought, that's a very good sign.
If you're in a submersible, stranded, trying to contact the surface and you had no communications, that absolutely is something one would do, which is to bang with a tool on metal, because that sound would travel a very great distance. But most importantly, you would do it very precisely and regularly.
The entire world is hanging on to these banging sounds. What if it is them?
They've been looking for the crew for 3 days, and we imagine the worst. But when we hear these sounds from the bottom of the ocean, we think, that's it. We found the crew of the Titan.
And from there, all of a sudden, the story is all over the news.
So we want to bring you a breaking update on that missing sub.
It's been confirmed that banging sounds have been heard.
Suenan de forma rítmica.
Less than 20 hours now left of air.
Faut absolument rester optimiste et se battre jusqu'au bout.
But this hopeful scenario also implies a horrific prospect, being locked in a tiny space down in the abyss. If the Titan's passengers are alive, they have been going through a living nightmare these past 3 days.
They are stuck in this tiny tin can at the bottom of the sea, in the cold and in the dark. And they know that they only have 24 hours of oxygen left. Each minute that passes is taking them closer to their deaths, so it's horrific.
It's a bit of a nightmare for everyone on board. You could compare it with the proverbial burying alive.
You can imagine that some of them are suffering from stress, suffocation, hygiene problems.
More serious than that is actually how cold it can get. The passengers on the Titan, if they were still alive, would actually have hypothermia. They would freeze to death before they ran out of oxygen.
With this in mind, the rescuers are pulling out all the stops as the final deadline approaches. If the crew isn't saved before 9:30 a.m. the next day, any chance of finding them alive will be wiped out. Thursday, June 22nd at dawn. It's as if time has stopped on the Titan's oxygen reserve countdown. 4 hours. In the best-case scenario, that's what remains for the Titan and its crew.
It would go right down to the wire, maybe, because the clock was still ticking. But that's it. We were going to get them back.
Even if there was some chance that they were still alive, people really wanted to believe it.
When Odysseus, the underwater robot, finally reaches the area, hope is rekindled. At 5:30 a.m., it begins its descent towards the wreck of the Titanic, to where the banging heard the day before was pinpointed. The whole world has its eyes riveted on this underwater robot. But it has to complete this formidable challenge in record time, because finding the Titan in this hostile environment seems to be mission impossible.
This is the 15-square-mile wreck of the Titanic, and a lot of that debris is bigger than the Titan. So this isn't looking for a needle in a haystack. This is looking for a needle in a needle stack.
Odysseus is steered from the surface on a pilot ship. So you have a crew that are viewing on the screen what the camera of Odysseus sees.
It spends a long time searching in the vicinity of where the sounds were picked up by the sonar buoy. In vain. Until the countdown timer stops.
There was this weird moment when we knew that time had run out, that the countdown had finished, and that at that point the Titan's passengers had no more oxygen left. With all our colleagues there on the docks, in front of the Coast Guard team, we looked at each other and said, "What's going on? That's it. It's over. We won't find them." But there was no announcement. And for an hour or two, we stayed like that, waiting. We were wondering what was going on.
At 3 o'clock in the afternoon, Boston time, on Thursday, June 22nd, the news breaks.
We're going to go straight to breaking news concerning that search for a submersible. Big debris field was discovered within the search area by one of the rovers near the Titanic.
Il n'y a donc ce soir plus aucun espoir de retrouver des survivants.
The wreckage makes it absolutely plain, but the worst possible outcome has happened. They find individual portions of the outside of the submersible and the broken up carbon fiber body. Tragically, there are no survivors.
Suleiman and Shahzada Dawood, Hamish Harding, Paul-Henri Narjolet, and Stockton Rush, the Titan's inventor, are all dead. OceanGate's submersible was supposed to allow them to fulfill their dream. It has become their casket.
That's when I said to myself that I would never see him again. And yes, it's still difficult to think that.
This is the grim epilogue to an unprecedented rescue operation with its many twists and turns, which for a long time prolonged the hope of finding them alive. These knocking sounds picked up in the ocean were just a false alarm.
The noises were not Titan. In fact, more ironically, a lot of them were actually Titanic. As the wreck slowly deteriorates, the deep-sea currents are gently moving things.
After this tragedy, it was time for the questions. What had happened? Was this tragedy a predictable outcome? Several alarming signs suggest so. Because while some wealthy tourists had fulfilled their dreams of seeing the Titanic with their own eyes, the expeditions of the Titan weren't all great successes. Far from it. In reality, during the 3 years that the submersible had been in operation, the majority of the dives didn't even reach their destination.
Out of 90 dives, 13 reached the Titanic. That means that this was a complicated expedition, which wasn't always successful. In fact, it was rarely successful.
Technical problems that meant that missions had to be aborted on a regular basis. Loss of contact with the surface, failure of the onboard computer or the sonar, and even loss of control of the submersible.
A communications problem is really a big technical worry because it renders the Titan blind, both for resurfacing and for moving about over the ocean floor.
It was a dive before my dive. The battery system failed, and they have no energy, so they have to make an emergency dive up. But what exactly the reason was, they don't tell us.
As a result, passengers who had paid for their descent were obliged to come back up to the surface without having seen the Titanic. As well as having been frightened by their experience, they weren't always refunded by OceanGate. The result? Through word of mouth, fewer and fewer people wanted to board the Titan.
In my opinion, it was a disaster for commercial. I was talking with him after the dive. I said, you have so many dives and not working, that's not good for commercial. And he said, yes, his shareholders are not very happy at the moment. And also he was asking me, maybe, are you interested to be a shareholder from us? But that's nothing for me.
Stockton came to see me in Las Vegas. He was really pushing hard for us to go. He assured me that it was safer than flying a helicopter or scuba diving, and I told him that my son had some safety concerns.
I actually found that video of Stockton explaining how the submarine was controlled with that game controller.
So, if you want to go
and I asked Stockton about it, and he got mad at me when I asked the questions, and he texted my dad that I was misinformed. So ultimately, I just told my dad, I'm like, yeah, we're just not gonna go because this guy is out of his mind.
Faced with this kind of attitude, Stockton Rush knew that his company's success was in jeopardy. He would do whatever it took to convince Jay and Sean Bloom.
To the point where he offered me a $100,000 discount for each of us. So instead of $250 a person, it would be $150 a person.
And we were just like, bro, like that's not the problem here, you know? No, he was definitely struggling to sell those tickets, and then unfortunately he found people that bought him. It was another father and son that took our place, those specific tickets.
This father and son were Shahzada and Suleiman Dawood. They weren't worried about the submersible's reliability, and they paid the full price to be part of the expedition. Just like Hamish Harding.
One of my friends, Hamish Harding, died, and I told him not to get in that submersible, but each individual has to make their own decision.
However, a form could have dissuaded them at the last minute.
Before going aboard, they had to sign a discharge in which the risk of death is mentioned 3 times on the first page.
A mere formality or a prophetic document? Ever since the Titan was built, various underwater explorers were convinced that people would die. Some directly warned Stockton Rush, but he refused to listen to them.
We routinely said that he was going to kill people, and he disagreed.
I know the Navy, the U.S. Navy raised the issues. Bob Ballard raised the issues. James Cameron raised the issues with him. He was not receptive to constructive criticism. You either agreed with him or he wasn't interested in what you had to say.
Worse still, when in 2018, the director of marine operations of OceanGate, David Lockridge, sounded the alarm and pointed out reliability issues with the Titan prototype, in particular with the viewport glass. The reaction of his boss, Stockton Rush, was categorical.
Stockton Rush brushed aside all of Lockridge's comments and fired Lockridge, and even said to him, "You're no longer in line with the company's philosophy. You're out of here."
And even worse than that, Stockton Rush also decided to free himself from any certification for his submersible, something which is like a crash test for every submarine.
Certification companies send engineers and inspectors to check that materials, safety systems, and components meet specific safety parameters. The Titan wasn't approved, and for a submarine, that is unacceptable.
Stockton Rush knew that his Titan would not pass any safety tests required for certification. But the CEO of OceanGate didn't care. He knew that where he was going, there were no laws that bound him.
Titanic is in international waters. If you've got the equipment and the money to go out there, then why not? Nobody's really going to be able to stop you if you really are prepared to push the boundaries.
Stockton Rush was therefore ready to take every risk, right up until this final dive on June 18th, 2023. Which would make the Titan known to the world in the worst possible way. A few hours after the debris had been discovered, the mystery remained intact. What had really happened aboard that day? On the docks of Boston, journalists were on tenterhooks waiting for the first pieces of information.
We wanted to know what had happened. We wanted to know how they had died, in what circumstances.
My father didn't have a death wish. People ask me why he went in the submarine. He believed in that submarine.
The final press conference of the Coast Guard would provide the first piece of the puzzle.
The debris is consistent with the catastrophic loss of the pressure chamber.
And he explained that the Titan had imploded during its descent.
An implosion is the opposite of an explosion. This external pressure wanted to get inside and crushed everything.
From the initial findings of the investigation, the experts believe that this implosion would have likely occurred at the moment that communication was cut, 1 3/4 hours after the dive began. But for an implosion to occur, that means there must have been a fault in the cabin. So where did it come from? Attention soon turned to the viewport. And David Lockridge, the former director of operations for OceanGate who was fired by Stockton Rush, was on everyone's minds.
We knew that these problems could be caused by the acrylic panes, which could split and crack.
Could the viewport have caved in under the pressure and caused the implosion? Not necessarily, because another element of the Titan was on the radar of all the experts, the component used for the hull.
Il est fait de fibre carbone.
Ein Zylinder ist aus Carbonfasern.
A carbon fiber, kind of an experimental craft.
So it's a very unconventional design, and I must confess that I was very concerned. Imagine a rope. A rope is very strong when you pull it, but it's not at all strong when you push it together. Carbon fiber is somewhat similar. It's great under tension, but not under compression. And when carbon fiber fails, it fails catastrophically. It doesn't bend or warp, it just snaps.
Could that be what happened? At this point, nothing can confirm that. But if that is the case, it offers some comfort to the families. Because a sudden implosion, however catastrophic that may be, means that the victims wouldn't have suffered.
It happened faster than the brain could even recognize what is happening.
An implosion is a horrible idea, but at least it's fast.
But not everyone agrees with this theory. Spanish engineer and submariner José Luis Martín puts forward another surprising hypothesis. According to him, the final minutes of the Titan's passengers would have been a journey through hell.
Something new had to have happened for this accident to occur.
It all began with a meteorological coincidence. The day that the Titan disappeared, the ocean current of the Gulf Stream was especially strong.
There was an incredibly powerful storm. The Atlantic was at its peak, with its waters churning in full force.
And so, according to José Luis Martín, the pilot would have forced the engines to ensure its descent, and so caused the batteries to drastically overheat. This inevitably resulted in a catastrophic failure.
A blackout. The submarine found itself with no electricity, no lights, no communications. The pilot was unable to activate any electrical safety system. That's when its journey to death and destruction began.
In this scenario, the Titan would have just been a dead weight at the mercy of gravity. Without any power for its engines, it would have lost its stability and tipped up, pushing the passengers to the front of the submersible.
Imagine that they are all piled up on top of one another. Imagine the feeling of fear, of terror, and of panic. I think it's the worst thing that somebody could experience. And in my opinion, at that point, they realized that these were their final moments alive.
Helpless, the passengers would have plunged in these conditions toward the depths of the North Atlantic Ocean. According to the Spanish engineer, the Titan would have sunk straight into the abyss at a rate of 22 meters per second, or 80 kilometers an hour, which is 20 times faster than on a normal dive.
It couldn't withstand an increase of around 100 kilos per square centimeter in less than a minute. That is more than enough to crush the hull of any submarine.
And according to José Luis Martín, the submersible would have been subjected to this huge increase in pressure during 52 seconds. 52 nightmarish seconds for the passengers and crew members, which would have resulted in the loss of any submersible. Inevitably, it imploded. But as terrible as this scenario is, could it have really happened? It is difficult to confirm while the investigation is still ongoing.
There have been horrific scenarios put forward. I think that people wanted to make a name for themselves by inventing theories out of nowhere. Personally, I believe that they didn't see it coming, and that they were there, happy, saying to themselves that they were going to see the Titanic. That's what I tell myself.
5 days after the discovery of the Titan's debris, human remains were brought to the surface with the aid of the robots. A final consolation for these families who needed to start the grieving process.
They managed to get their DNA, so they should be sending us things that have their DNA. But we don't know when, and we don't know what that is. And it's not nice to imagine what it could be.
Other pieces of debris from the Titan, some parts of which remain almost intact, have also been recovered. Analyzed by experts, they will offer precious clues to answer the questions on everyone's lips. If the Titan imploding is the most likely scenario, what caused it? Would the passengers have been aware that they were going to die? And above all, since Stockton Rush died with his creation, who will have to assume responsibility for this tragedy?
Who is responsible for these 5 deaths? Who didn't do their job properly?
Son travail.
Unlike aircraft, there's no black box, there's no data recorders for the Titan submersible. The investigation will come to solid, definite scientific conclusions, but it's got its work cut out for it.
It will undoubtedly take several years before the investigators deliver their findings. Will the Ocean Gate Company and its owner, Stockton Rush, be found guilty of serious safety breaches?
Complaints have been filed. There will be trials, that's for sure.
The commercial aspects caused them to have safety protocols that weren't as stringent as they needed to be.
It was inevitable that the Titan would implode.
This tragedy will long be remembered. The whole world followed the unbearable suspense of the search, in the hope of finding the Titan's passengers safe and sound. But there was no happy ending. More than a century after it sank, the Titanic had just claimed 5 new victims.
I feel horrible for the father and son that ended up going, and it's crazy because we were very, very close to going on that trip. Like, thank God we didn't go.
One final consolation for Paul-Henri Nargeolet's daughter. Her father would have lived his passion for the Titanic to the very end.
My father had an extraordinary life. He was happy to be going to see the Titanic one more time. For him, it would have been a good way to die. But for me, as we don't have a body, there are still times when I think, maybe he'll come back. I don't know.
While there are still thrill seekers out there, extreme tourism will have a bright future ahead of it.
I have a ticket to space by Richard Branson, and it should be working maybe next year. From the deep to the space, yeah.
It all comes down to money. It all comes down to someone who's willing to do it.
If Elon Musk said, hey, do you want to go on a ride? I'd say, sure. But with all due respect, if you invited me to go on a rocket ship that you built in your backyard, I would probably decline.
Other people want to build submarines for tourists, and I think that it's a good idea to do that. We shouldn't close the door of the ocean to tourists just because there was an accident.
More than a century after the Titanic sank, and at the cost of 5 more human lives, the tragedy of the Titan echoes the fate of the ocean liner that was believed to be unsinkable. When man defies nature, he sometimes has to pay the price.